Hello everyone, my name is Payal Kamble.
And my name is Mangesh Venkatraman. And we are here to present maths IC number 1, which is our problem statement is homemade weight bottle rocket is launched from the ground. The launch is filmed with a mobile camera, and subsequent analysis allows the rocket's height above the ground to be measured every half second and enter into table 3.9. Determine the suitable model that describes the rocket's height above the ground and calculate when the rocket will hit the ground. We have sufficient data for this calculation, and the mathematical formulation of our problem is let assume the rocket follows uniformly accelerated motion, neglecting air resistance. So height as a function of time can be modeled as h of t is equal to at squared plus bt plus c. Where ht is a height at time t, and where now is we are solving this problem by quadratic equation, and we are finding the regression according to the values given in the table. This is the time, height, and this table is t square, means square of times its cube, its fourth power, and product of time and height, and this last is a t square into h, is time square into height. Now substituting these values in matrix and solving this by matrix method, we get this, and substituting the previous values, and to find the values of C, A, B and C, we are equating this matrix, and after multiplication of matrices, we get the three equations. We get equations and substituted in a matrix and equating with these numbers. These are the four equations we get. Now equating them by linear equations by elimination method. We get the three equations from the matrix, and now equating the linear equations by elimination method. We have to eliminate only one variable from this equation, and let equating equation 1 into 13.75 minus 7.5 into equation number 2. Then we get equation number 4 in terms of A and C. Similarly, for equation 2 and equation number 3, we are equating by multiplying equation 4 by 21.875 and multiply by equation 5 by 26.25. We get the equation number 6 and 7, and this value in terms of A. Similarly, similarly equating equation 3 and 2 by multiplying equation 3 by 13.75 minus 7.5 to equation number 2. Then we get equation number 5 in terms of also A and C. Then now multiply by equation 4 to 21.875 and equation 5 by 26.525, we get equation number 8 in terms of only A, and from this equation we are able to calculate the value of A, which is minus 3.95, and substituting this value of A in equation number 7, we get a value of C, which is equal to 0.35, and solving for B, we have A is equal to minus 3.92 and C is equal to 0.35. Now we have to find the value of B. Then using equation number 1, the value of B is 12.864.
Using matrix solution, we get A, B, C values. Then h by t is equal to minus 3.92 t square plus 12.864 t plus 0.35. By using the quadratic formula, we get before the values of A, B, C, then we can put it in the value in formula. T is equal to minus b plus minus a under root b square plus 4 is c divided by 2 by a 2a. Putting those values in the equation and we get the solution in two ways. By solving the equation we get the two values, positive and negative, but negative is not possible for the time, so we solve it again. Then we get the value 3.30. The ground, the rocket hits the ground again at t is equal to 3.30 seconds. We plot the graph. The graph will start from 0 to. We plotted every value from the table, where on x-axis there is time and on y-axis there is height. On first we started from 0 to 0. Then again second plot is 0.5 and 6.23. Then again 1 and 9.56. Then again it reaches to the height 1.5 and 11.05. Then again it gets down from the table 2 and 9.26. Then again it gains down 2.5 and 8.61. Then again it touches to the ground where 3.30909 and 0. Then the quadratic regression is at 3.3090 and 3. 92 t square plus 12.864 t plus 0.35. Then rocket hits the ground again is equal to t is equal to 3.30 seconds. The model type is quadratic projectile motion. The quadratic model h of t is equal to minus 3.29 t square plus 12.864 t is equal to minus 0.35. Accurately describes the projectile-like motion. The rocket reaches maximum height at about t is equal to 1.5 seconds. Then the rocket hits the ground again at t is equal to 3.30 seconds.